Hey there, this is Mr. Alexander again. I'm going to show you a few more factoring problems today. And I'm starting right here with y equals x squared plus 9x plus 20. And the way I like to think about these are through two ways. I want to think about the values a times c and the value of b. Remember, a is the number in front of the x squared, b is the number in front of the x, and c is the number on the end when you're in standard form there. So a is 1 in this case, and c is 20, b is 9. So 1 times 20 is just 20, and then b is 9. So we're looking for two numbers that multiply to 20, but also add to 9. So two factors of 20 that add to 9. And the numbers that pop in my head are 4 and 5. So when you rewrite this, you're going to write it as y equals x plus 4 times x plus 5. Now to solve it, we need to set it equal to 0. So I'm going to get rid of that y. I'm just going to put a 0 right there. And once I've done that, the whole nice thing about factoring is I can take each of the individual factors, x plus 4 and x plus 5, and set them equal to 0. And then from here, we're just solving. So x plus 4 equals 0, x plus 5 equals 0. That means that x must equal negative 4, comma, negative 5. Those are my two solutions. Same thing over here. We've got x squared minus 6x minus 16. I want to know a times c, which in this case is 1 times negative 16. And I also want to know b, which is negative 6. I'm looking for two numbers that multiply to negative 16, but also add to negative 6. So the numbers that pop in my head are negative 8 and positive 2. So when I rewrite this thing in factored form, I'm going to write x minus 8 times x plus 2 equals 0. Because when we're solving it, we're going to get rid of the y, we're going to substitute a 0 for y. Once I've done that, I can set x minus 8 equal to 0 and x plus 2 equal to 0, giving me the solution of x equals positive 8, comma, negative 2. But as you talked about last class, these factoring problems come in varying degrees of difficulty. The a is not always equal to 1, but the process is exactly the same. You still want to know a times c, and you still want to know b. So in this case, our a is 2. So we're going to do 2 times 2, which is 4. And our b is negative 5. So now what I'm looking for are two numbers that multiply to positive 4, but also add to negative 5. And hopefully you recognize that as negative 4, comma, negative 1. Because negative 4 times negative 1 is positive 4, and the negative 4 plus negative 1 is negative 5. So now, when we rewrite this in factored form, I'm going to go ahead and put in a 0 for y, because I know I'm solving it. And I'm going to write my factors x, and I'm going to write my minus 4 and my minus 1. But now, I know that the a isn't equal to 1, it's equal to 2. So this is the part where I need to write that a value 3 times. I want to write it in front of the parentheses. I want to write it, divide that 4 by 2 and divide that 1 by 2. So that's the only tricky part when these a's are not equal to 1, is you just have to write that a value in 3 different spots. Well, hopefully you can see this is in factored form. And I can reduce that fraction a little bit. I can make this 0 is 2 times x minus 2, because 4 over 2 is just 2, and x minus 1 half. I'm going to take my factors and set them equal to 0. I'm going to ignore that 2. I'm going to ignore that a value, simply because setting 2 equal to 0 doesn't make any sense. But another way to think about it is if you divided both sides by 2, that would disappear, and that 0 wouldn't change, because 0 divided by anything is still 0. But I'm going to take my two factors, x minus 2, set it equal to 0, and x minus 1 half, set it equal to 0. And now, hopefully you can see that x equals 2 and positive 1 over 2, or 0.5 if you prefer a decimal. All right, let's talk about one more here, where the a is not equal to 1. I still want to know my a times c, and I still want to know my b. But now I've got 9 times 4 for my a times c, which is 36, and my b is 12. So I'm looking for two numbers that multiply to 36 but add to 12. And that would be 6 and 6. So when I rewrite this, I'll substitute in a 0 for the y because I'm trying to solve it. I'm going to write my factors, x plus 6, x plus 6, but then I'm going to take my a value, which is 9, and write it in 3 places. I'm going to write it here, here, and here. So I can rewrite this factored form. 6 over 9, that's just 2/3. So I've rewritten the equation. Now I'm going to take my factors and set them equal to 0. I'm just going to ignore the 9 because I can't set 9 equal to 0. That doesn't make any sense. But I can say that x plus 2/3 equals 0 and x plus 2/3 equals 0. Well, you might remember from last class that we talked about you can have a maximum of 2 solutions in a quadratic, but in this case we're going to have one real solution, and that one real solution is just x equals -2 over 3. You can also have 0 real solutions, so you can have 0, 1, or 2. In this case, it's just 1. Last two. X squared equals 49. Well, remember we need to have a 0 on one of the two sides to solve it. And then hopefully you instantly recognize this as the difference of two squares, because x squared is a perfect square and 49 is a perfect square. So to factor the difference of two squares, you ask yourself the question, what's the square root of x squared? Well, that's just x. And what's the square root of 49? Well, that's just 7. And then in between there, we're going to write a plus and a minus. So when we factor this thing, we've got x plus 7 times x minus 7. My solutions then are x equals positive and negative 7. Same thing over here. We're going to make this 4x squared minus 81 equals 0. And 4 is a perfect square, x squared is a perfect square, 81 is a perfect square. So I'm going to recognize this as the difference of two squares. Square root of 4 is 2. Square root of x squared is x. Square root of 81 is 9. It's going to be 2x plus 9, 2x minus 9 equals 0. So I'm going to set each of these equal to 0. And I'm going to end up with x equals positive and negative 9 over 2, which is equivalent to positive and negative 4.5. That's it. That's all the factoring that we're going to do today. Thanks for watching this video. We'll see you next time.